everybody, welcome to my video again. Today in this video I'm going to discuss about a problem in linear programming. So what we have to do here is we have to optimize the given objective function. So optimization means we have to either maximize or minimize the given function. So certain conditions are given here, we call them constraints, and the constraints are linear inequalities here. So given constraints are here: x minus 2y is less than equal to 1, so that is our constraint 1, and another one is x plus y is less than equal to 4, that is constraint 2. Next one is x is greater than 0, so that is 3, and the fourth constraint here is y is greater than equal to 0, so that is our constraint 4. So these four constraints are given to us. These are inequalities here, so we have to plot them. To plot them in graph, first we need to find the boundary lines. So now boundary line equation for inequality 1 is given by x minus 2y equals 1. So to plot this line in graph, at least we need 2 points here. So let's find those 2 points. So let's put the value of y equals to 0 in first place, and the value of the corresponding value of x for y equals to 0 is 1. Now we got our first point here 1 0, and for the next point let's put y is equal to 1, and the corresponding value for x will be 3. So now we have 2 points here. Now we can plot the straight line. Now we have to go for another inequality here. X plus y is less than equal to 0, and the boundary line equation for this inequality is x plus y is equal to 4. Let's write it. So this is our boundary line equation. Now for graph we have to find 2 points to plot this boundary line. So let's find 2 points here. So this is pretty easy here. X plus y equals to 4 means we need those values of x and y for which the sum is 4. So the easiest one is 0 4 and 4 0. So x plus 0 equals 4 will give us x equals to 4, and 0 plus y equals to 4, we are getting y equals to 4. Now the first one is for value of y equal to 0, and the second one is for value of x equal to 0. So now we got our 2 points 0 4 and 4 0. Now other two inequalities are here. X is greater than equal to 0 and y is greater than equal to 0, and the boundary line equations for these two inequalities are going to be x equals 0, so that is our y-axis here, because in y-axis all the values of x are 0, and next one is y equals to 0, so that is our x-axis. These are the boundary lines for the given inequalities 3 and 4. So here for first boundary line we have the points 1 0 and 3 1. So we plot the straight line there. So this gives us a boundary line. So now we have to shade the region here. So to shade we use origin test here. So what we'll do is we'll put 0 0 for x and y, and if the result is true then we shade towards the origin, and if the result is false we shade towards the region where origin is not present. So here our result is true, hence we have to shade towards the origin. After plotting all the boundary lines, so let's shade the regions here according to inequality. For the first inequality we have to set as shown on the screen there towards the origin. And for second inequality, we'll type the inequality there. X plus y is less than equal to 4. In this case also we have to set towards the origin. Now the next inequality is given by x is greater than equal to 0, and now that is our y-axis, and as x greater than 0 simply means the right side of y-axis, so that is how we say it. Now another one is y is greater than 0, so that means upwards, the region upwards from x-axis. So we have all 4 inequalities here, and we have shaded all the regions here. Now we have to find a common region, the region which contains shades for all inequalities. Now that is OABC. The coordinate of O is 0 0, and that of A is 1 0, that of B is 3 1, and that of C is 0 4. So the region OABC is our feasible region. We also call it the convex polygon. So we have noted down all the vertices of the convex polygon here, so OABC here. Now what we'll do is we'll note down all the points and we'll find the value of objective function at these points in tabular form. So let's write all the points and find the value of objective function. So let's find the value of objective function at 0 0. So it's going to be 0 here. At point 1 0, it is 5 into 1 plus 4 into 0, that is 5 here. At point B31, we have 5 into 3 plus 4 into 1, and that is going to be 5 3s are 15 plus 4 equals 19. And for the fourth point, the value of objective function is going to be 16. So here we see that the maximum value here is 19 at 3 1, and the minimum value is 0 at point 0 0. This is how we find the maximum and minimum value of objective function under the given constraints. So this is how we optimize the given objective function. I hope this video is helpful to you all. See you next time in my next video. Till then, bye bye.